We started off wondering how bean plants would be affected by contamination of water by acetaminophen because acetaminophen is one of the most commonly used medications in the United States, and with the wrong disposal of it, it can end up in plants, water, and soil. And we looked through a series of studies to kind of determine how bean plants might be affected by the contamination. One of the first studies we looked at was done by Huma and their colleagues, and they discovered that metal-resistant plants were resistant to pharmaceuticals and non-metal resistant plants were not. So they experienced some adverse effects from the pharmaceuticals in the water. And then we looked at a study done by Beckley and their colleagues, and they tried to determine whether bean plants were non-metal or were metal resistant or not. They determined that bean plants were not metal resistant. We found a study done by Suzuka and their colleagues, and they discovered that plants that weren't metal resistant would have some adverse effects to acetaminophen. These effects included a reduced growth rate. After looking at all this information, we came up with our null and alternative hypotheses. Our null hypothesis was that acetaminophen would not have an effect on the plant growth rate, and then our alternative hypothesis was that acetaminophen would have a benefit on the growth rate. And then after we come up with our hypotheses, we decided to treat the bean plants with different concentrations of acetaminophen in their water. When we set up our experiment, we took 36 recently sprouted kidney beans and potted them separately into their own individual identical pots and covered them with topsoil. Each group that we did had 9 bean plants, and there was 4 different groups. One group, our control group, had no acetaminophen in the water, and then there was 3 other testing groups, being 0.13 grams per liter, 0.26 grams per liter, and 0.4 grams per liter. The plants were watered with 50 milliliters every Monday, Wednesday, and Friday morning for 4 weeks, and every Friday we would go in and we would measure the plant stem length from the soil to the highest leaf, and we recorded it in our notebooks. Every week we would average out each group's set of data to find out what their average growth rate was, and with this we used t-tests to compare the difference between the growth rate of one plant group to another plant group. Then we performed a t-test on the average growth rate of the control group to the average growth rate of the experimental group that had 0.26 grams per liter of acetaminophen in it between the second and third week, because those proved to be the most different from each other at that time. After we did that, we decided to graph the information into 2 graphs. One is a bar graph that showed the information of the week 2 to 3 averages of all of the groups. And then in the second graph that we did, we graphed each of the averages and we tried to find a correlation between the bean plant growth rate and the acetaminophen concentration. And then for the results section, we have our t-test results, as I said before, that we tested for the control group and the treatment group that had been exposed to 0.26 grams per liter of acetaminophen between the weeks of 2 and 3. And we found the t-value was 0.074, and our t-critical value was 1.746. So with this information, we could determine that there was no significant difference between the growth rates of the control group and the treatment group. Underneath our t-test results, we have our graph that shows the average growth rate of the 9 bean plants for each treatment group. And you can see that the control group, labeled 1, has the lowest growth rate during weeks 2 to 3, and that our third group, the group that was treated with 0.26 grams per liter experienced the greatest growth rate during this period. Next, my partner Mary is going to go over figure 2 with you, along with the conclusions that we were able to make from our experiment.
Hello everyone, my name is Maria Padron, and in this experiment my partner and I decided to do increasing concentrations of acetaminophen with the purpose of developing a correlation graph between the concentration of acetaminophen and the plant growth rate. This graph was done with the data obtained from the time interval of week 2 to week 3, just like figure 1. On the x-axis, we represent the concentration of acetaminophen, and on the y-axis, we represent the growth rate in centimeters per week. Figure 2 is similar to figure 1 in the sense that you can see that the growth rate increases as the concentration of acetaminophen increases up to a certain point, and then it begins to decrease. So the first point is going to be the control group at 0 grams per liter, and the next 3 groups are our experimental groups. So we have 0.13 grams per liter, 0.26 grams per liter, and 0.4 grams per liter respectively. With this graph, we found our correlation factor to be 0.26. Now, our results were a little bit different from what we were expecting. We hypothesized that the plants that were exposed to acetaminophen would have slower growth rates when compared to the control, and we actually found it to be the opposite. We found that the control had the slowest growth rate out of all the groups, and the 0.26 gram per liter group had the fastest growth rate. However, we did not find these differences to be significant. As my partner explained, we performed a t-test at the 95% confidence level with 16 degrees of freedom for the group 1, the control, and group 3, the 0.26 gram per liter group. Our t-value was calculated to be 0.074, while the critical value is 1.746. In order for the differences to be significant, the t-value that we find has to be higher than the critical value, and in our case, it was much lower. And this is because there was a lot of variance between the groups, so we cannot say at the 95% confidence level that these two treatments are significantly different. And it is because that these two groups are not significantly different that we cannot reject the null, and therefore we must accept it. The null says that acetaminophen has no effect on the plant growth rate, and we actually find the same results from figure 2. The correlation factor from figure 2 was 0.26. In order for a correlation to be strong, it has to be closer to +1 or -1, and in our case, it was very close to 0. This means that there is no correlation between the concentration of acetaminophen and the plant growth rate, meaning that we must accept the null. However, during the experiment, we also did some qualitative observations. We found that the plants that had acetaminophen in them appeared significantly healthier than those that didn't. This is because, as we all know, during the weekends, we didn't have access to the greenhouse and we weren't able to water the plants. So every Monday when we walked into the greenhouse, we saw that the soil from the plants that had acetaminophen was moist, while the ones for the control groups was completely dry. We think that this is because the acetaminophen may have affected the water in a way that made it harder to evaporate. So it kept the soil moist for longer, and the plants had access to water all the time, therefore appearing healthier after 2 days without watering. We think that this may have affected our results because the control group that had the slowest growth rate did not have access to water during the whole week, while those that did were the ones that showed the highest growth rate. However, the plant that had the highest acetaminophen content was the one that was always completely moist, but it doesn't have the highest growth rate. Therefore, we don't know what the actual effects of acetaminophen are on the plant's health. We believe that more testing should be done regarding what the actual health effects of acetaminophen are on the plant, because growth rate may not be representative of these effects. Also, we believe that there should be more testing done to figure out what the effects would be if there was a prolonged exposure to acetaminophen, because our experiment was performed only for 4 weeks. We also believe that there should be more testing done where the temperatures are controlled, because at the beginning of our experiment, the temperatures were cooler, and as it progressed, the temperatures began to rise, which caused the water to evaporate quicker, and this might have affected our results. Also, the temperature may have an effect on the plant growth rate, and we cannot assume that this is not a confounding variable because the temperatures did vary during the progress of the experiment. Finally, we believe that it would be interesting for more research to come out regarding other types of pharmaceuticals because acetaminophen is not the only widely used pharmaceutical in the US. For example, birth control is very popular and it is a hormonal drug, so we don't break it out completely and it ends up in the water supply and we don't know what its effects would be on the plants. We would like to thank Dr. Thompson for the sprouted seeds, the topsoil, and the access to the greenhouse, and we would also like to thank Dr. Mary Whitwell for giving us the acetaminophen that we used in this experiment. Thank you.